RO system. What is RO? RO is used to produce highly purified water for drinking water systems, industry boilers, food and beverage processing, cosmetics, pharmaceutical production, seawater desalination, and many other applications. RO is a special type of filtration that uses a semi-permeable thin membrane with pores small enough to pass pure water through, while rejecting larger molecules such as dissolved salts and other impurities such as bacteria. Principle of RO system. RO works by reversing the principle of osmosis, the natural tendency of water with dissolved salts to flow through a membrane from lower to higher salt concentration. About RO membranes. A RO system is built around its individual membranes. Each membrane is a spiral bound sheet of semi-permeable material. Membranes are available in varying diameters. The industry has accepted a 40-inch length as a standard size so that membranes from different manufacturers are interchangeable in equipment systems. Membranes are of 350 to 450 square feet of surface area. Semi-permeable membranes were first constructed using cellulose acetate, but later the industry switched primarily to the use of thin film composite, also known as TFC, being placed on the top of strong substrate. TFC membranes are primarily used today. How does an RO work? RO is continuously operating treatment technology that uses to pass source water through a thin membrane and thereby separate impurities from water. In RO system, pressure is used to overcome natural osmotic pressure, forcing the feed water with dissolved salts and other impurities through a highly sophisticated and semi-permeable membrane that removes a high percentage of the impurities. The product of the process is highly purified water. The rejected salts and impurities concentrate above membrane are passed from the system to drain onto other processes. In a typical commercial industrial application, 75% of the feed water is purified. The application in water is conserved is important. 85% of the feed water is purified. An RO system uses cross filtration, where the solution crosses the filtration with two outlets. The filtered water goes one way and the contaminated water goes another way. To avoid build-up, contaminants cross-flow filtration allows to sweep away the contaminant build-up and enough turbulence to keep the membrane surface clean. Our product overview. The output from RO systems actually divided into pure water and wastewater. So pure water is used as drinking water, whereas as wastewater is considered for other uses like watering plants and cleaning, etc. Normally, this was the existing method for usage of wastewater. We are going to build a product that will be very useful for our future generation, by which we can reduce the water scarcity. The aim of our product is converting wastewater from RO system into distilled water by further process. By converting this, we can save the money instead of investing in distilled water. And actually suitable for our daily life, we can use distilled water in different ways, and usage of distilled water is discussed in the following slides to come.
Here I am to explain the various parts of an RO system. The exterior parts are as followed. There is a 5 micron sediment filter. It is made up of fine melted polypropylene. The main function is to remove large and fine particles from drinking water such as sand, dirt, silt and rust. Then there are 2 filters to remove chlorine. A 10 micron carbon filter which uses radial flow carbon block to remove chlorine and organic compounds to deliver clean water to every home. Then the granular activated carbon polishers which are also used to remove chlorine from water. There are a lot of differences between GAC and carbon block filters, which makes one type better suited for certain applications compared to the other. The last part of the RO system is the pressure gauges that are used to monitor the pressure in a water line. Next we are to discuss the interior of a RO system. There are 5 important stages to purify water. The first stage is the sediment stage, which removes rough particles, sand and rust. The second and the third stage is the pre-carbon stage, which removes chlorine and harmful chemicals. The fourth stage is the reverse osmosis stage, which removes dissolved solids and virtually everything larger than the water molecule itself. And finally, the fifth stage is the post-carbon stage, which removes any taste odor that is acidic that has been picked from the storage tank.
Actual process for preparing distilled water. In general, distilled water is prepared through the process of distillation. In the process of distillation, pure water is boiled out of its contaminants. Many contaminants found in water are inorganic minerals, metals which have very high melting points. So, water is easily separated using simple boiling. But there is a problem with this process. There are so many volatile organic compounds found in water, and many of them have boiling point which is less than water. So, when boiled, the volatiles are boiled off first, then water next. So, these contaminants affect the steam. So, it is very important to have additional purification technologies besides only distillation to make sure all the bad stuffs are removed. The process of distillation is one of the technologies used to purify water. RO is another technology that is used to purify water. The big difference is that boiling water consumes a tremendous amount of energy. All the water has to be boiled until there is none left. Conversely, RO technology consumes far less energy. Commercial systems like ours utilize energy efficient pumps to perform their purification, and the end result is more effective. The usage of distilled water has many advantages. In future, this process will be very useful for us. RO-WAD converter. This is the main process. Reverse osmosis wastewater to distilled water is actually named as RO-WAD converter. By the actual process of the distillation, we are going to place two metal tubes mainly large in size. The contaminated water from the RO system is allowed to flow through a tube and is flowed into the RO-WAD converter. The device consists of two tubes, which is actually mentioned as metal tubes in previous point. One of the tube is made of steel, which is act as boiler, and the other is made of glass. Why? Because this one is used for cooling process. And next, the water goes into the boiler to heat it in definite temperature, and after some time steam is formed. The tube has small pores to eliminate the vapors formed during the boiling process, and some organic substance present in it will be settled down at the bottom of the tube. Steam is taken into the next tube to take down cooling process. The cooler is mainly used here to reduce the temperature of the steam. And finally, the water is extracted as distilled water. Merits of RO-WAD converter. The main easy thing is we can prepare distilled water at home. It is not necessary to buy distilled water for high cost. We can use the distilled water for UPS batteries and other electrical appliances. We can activate RO-WAD converter whenever we want. If we have trouble by getting plenty of distilled water, we can sell distilled water to gain some money. In future, this product is very helpful for all. Demerits of this product. During this process, the wastewater gets boiled the organic compounds which has lower boiling point than wastewater gets evaporated and affects it. So the distilled water gets some trouble. To avoid this, impurities are added to break down the organic compounds. We won't use distilled water regularly. We need some containers and to store distilled water. Do not cool the distilled water because it has chance to break the container. The boiling process consumes more electricity. To overcome this, we can go on solar energy or battery. This distilled water will not conduct electricity, and this is strictly not for drinking.
Grey water. Water used in homes has long been thought in terms of clean drinking water known as potable water coming into the house from the mains and sewage going out. Wastewater from bath, shower, sink are referred to as grey water, whereas the water used in toilets which comes into contact with human waste is known as black water. Grey water recycling. Grey water is never going to be safe to drink even when they are treated. Reclaimed grey water can be used to flush toilets, wash clothes, etc. Various ways to treat grey water. There are various methods to treat grey water ranging from simple to complex method. First one is direct use system for watering plants. Here, the grey water is directly taken from bath or sink and taking this through an external pipe and allowing to a water bed or a flower bed. Second one is biological system, non-food debris. It consists of two types, sand filter method and wetland method. In sand filter method, the sand-sized particles are removed through a filter. It is then filtered using a very simple soil box consisting of 4 layers of materials. Wetland method. In this, the grey water is treated using a wetland, that is, the water is retained, that is close to the surface, allowing an aquatic plants such as reeds, bulrushes to flourish. The roots of these plants absorb dissolved organic materials. Third one is biological system, food debris. Grey water is treated anaerobically with a soil box, filter or using a wetland. Mechanical filter for flushing toilets. It is a simple process to undo the U-bend under a sink and capture the wastewater in bucket which could then manually pour into the cistern of a toilet. Benefits. Recycled water can meet a variety of water supply needs and reduce the impacts of water supply. There is a reduction in the amount of pollutants entering the rivers and water system as less grey water need to be commercially treated.